All right, hello everyone. Welcome to today's webinar on integrating R with ArcGIS. This is part 2 of a 2-part webinar series. Part 1 is already available online, and I've provided links to that to everyone who has registered for this webinar. My name is Cameron Plouffe. I'm a higher education developer / analyst at Esri Canada. You can contact me at cplouffe@esri.ca, and I'll also provide contact details on the last slide of this presentation. So before we get started, just a few notes on WebEx. So when you join the webinar, you're prompted to join the audio broadcast. And last week we experienced some audio connectivity issues. So we wanted to recommend that this week you connect by phone instead of by using your computer speakers, as we found that once a certain capacity was reached, people started to have audio connectivity issues with the computer speakers. So please use your phone and dial in using the toll-free number provided on the screen. For the best view of today's presentation or any demonstrations that I'll show, please click the full screen button indicated on this slide. It's located in the WebEx toolbar, and I would recommend this as a lot of coding examples in the RStudio IDE will be done during this week's webinar, and it might be difficult to read them if you're not full screen. At any point during the session, if you want to click this big blue return button, that'll bring you back to the default view. So as far as questions goes, you can, throughout the session, if you have any questions, you can choose Ian Greensmith's name from the chat panel, and you can click this button right here to toggle the chat panel. Choose Ian Greensmith and type your question in the box below, and then click send. I'll be answering questions at the end of the presentation, so don't think that I'm not answering your question if you do send a question to Ian. Be sure to choose Ian is the host, so he'll also have a host icon beside his name. If you'd rather email me offline, that's entirely fine. I'll have my contact information again on the closing slides. And lastly, this session is being recorded just like last week's webinar. So the recording and the presentation, plus the materials for the webinar, will be made available in an email after the webinar. Okay, so let's get into the webinar schedule. So this is assuming that you were attending or already watched the video of last week's webinar. So we'll be building on a lot of the concepts from that. So we'll do a quick review of the ArcGIS Binding package. Then we'll cover what is an R-script tool and some of the basic components of an R-script tool. One of the most important components of that is the r-arcgis or the R script associated with that tool. So we'll go through writing an r-arcgis script. I'll show you a simple tool template that we can use, and then walk through several different examples of r-arcgis tool scripts. After that, we'll construct the R-script tool within ArcGIS, and specifically within ArcGIS Pro. And that basically just goes, you'll be assigning different script tool parameters within ArcGIS, and maybe providing a little bit in the way of tool documentation. And then lastly, we'll talk about using R scripts in a ModelBuilder workflow, which is really powerful because you can integrate a lot of different environments for performing the best possible analysis. Okay, so very quick review of the ArcGIS Binding package, as we have a lot of material to go through. So the ArcGIS Binding package in R allows R users to access data stored in ArcGIS native data types, for example, geodatabase feature classes, and you can use the arc.open, arc.select, and arc.write functions to interface directly to these data types. You can convert ArcGIS data to an SP or a spatial object in R and perform some analysis, and then when you're done, you can write that back to a geodatabase. And you can use the arc.data2sp and arc.sp2data functions to help you accomplish this. You can convert between Wicket and Plouffe projection strings using arc.from P4 to Wicket and from Wicket to P4. And lastly, if you want to only interact with geometries and you don't want to work with any of the attribute data, you can use arc.shapeinfo and arc.shape2sp to do so. And here's a link to the package documentation. So I'm going to quickly go through some of the examples that we covered last week in the Integrating R with ArcGIS Part 1 webinar. So first things first, I'm going to load up the packages, the SP and dplyr packages. And I'm going to scroll right down to the ArcGIS Binding section. We're just going to blitz through some of these very quickly. So the first thing you want to do is you want to load up the ArcGIS Binding library. And it will prompt you to call the arc.checkProduct function, which will check that you have a license for ArcGIS on the machine that you're working on. And as you can see, I've been successful. I have an ArcGIS Pro license. So now we can use the arc.open function to read in ArcGIS data into R. So let's define an input FC location. This is just a string that's pointing to the data set you want to look at. We're going to continue working with our Toronto crime data set and use the arc.open function, provide that location, and that will create an ArcGIS data set and connect to that in R. So we can check the class of this, see that it's an ArcGIS feature implementation. So now, if we want to create a data frame from this, we can use the arc.select function right here. So arc.select will allow you to sort of create a data frame that retains the spatial attributes of that shape or of that feature class. Here we're going to specify that we want to get all the fields from this data set. So let's do that quick, and let's actually use the view function to view this data frame very quickly and get an idea of what we're working with. We'll see it comes out in a nice spreadsheet-like format. You can see that we've got different neighborhoods of Toronto and all these different crime categories that we were working with last week. Great. So we can perform some sort of analysis or some data manipulation on this. Say we want to add our population density field. We can divide the population column by the area. We can also do the number of crimes per total major crime incidents per 1,000 inhabitants in each neighborhood. We can calculate some quantiles, so we can create quartiles based on the equity score column in the major crime incidents column per 1,000 inhabitants using the entile function available from the dplyr package. And we can add those back to our data frame by specifying a column name that we want to add. So equity rank and crime rank. Lastly, we can use some of the advanced functionality from dplyr to do some summary statistics for each one of our crime rank groups that we just defined. So we can say summarize df, and then we can use the forward pipe operator that we covered last week to keep piping in the data to the next function. I'm just going to execute this all at once, and then we'll attach that back to our original data frame, and then we'll take a look at the results. And again, I'm going very quickly through this, but this was covered in last week's webinar, so it's a very fast review. And we can see, we scroll to the end of the data frame, and all of these new columns have now been added to our data set. So that's great. The last thing we would want to do is define an output location for our feature class. So this is just the same geodatabase as with the name Toronto Crime Group. And then we can use the arc.write function to specify the output location and then the output ArcGIS data frame to write to that location. I'm not actually going to do that, but we did do that last week and we saw the result in the ArcGIS geodatabase. Okay, let's go back into the presentation. So now that we know we've reviewed the ArcGIS Binding package, that deals explicitly with interfacing to ArcGIS from within R. But what if we want to do the inverse of that? We want to interface to R from within ArcGIS. And in that case, you're going to want to build an R script tool. So what is an R script tool? If you've ever worked with Python script tools, then you'll be very familiar with this process. But essentially, similar to Python, ArcGIS allows you to write scripts in R that can be called directly from within ArcGIS. You can create a GP tool that uses R for analysis, and then later on we're going to cover how you can sort of streamline these things together. You can work with Python, R, and native ArcGIS GP tools in a model and reproduce some pretty complex workflows, so it's very useful. There are three main components to all R script tools, and these are sort of overarching components that you'll need. The function will not work, nothing will work correctly if you do not have all of these components. So an R script, this is the most important component, a custom toolbox that you're storing your GP tool in, so a .tbx, and a definition of the parameters of your script. And this is going to be done in the actual ArcGIS Pro GP tool, or the script tool, sorry. So the most important component of an R script tool is the R script. So that's what we're going to spend the majority of today covering, is how to construct these R scripts. And the first thing you need to know are the basic components of an R script. So all R tool scripts follow the same general form. They have three important things that you need to include in every one, and the most important of which is the tool exec function. So I'll be showing you this in a second, but toolExec is a function that will be executed when the R script is called from an ArcGIS script tool. So essentially, whatever script you've connected, it's going to call this tool execute, I guess it's short for, function, and then it's going to execute whatever's in that function and return the results back to ArcGIS. The first argument of the toolExec function is the in-params. So this is just the input parameters that are provided to the script from ArcGIS. So it's a list, it's an R-type list of input parameters provided from the GP tool. The out-params is the second argument of the toolExec function, and this is exactly what you'd think, a list of output parameters provided from the GP tool. And this isn't always required, but if you do want to write your data back out to an ArcGIS data set, then you will probably be required to provide some output parameters. Okay, so we covered most of the functions from the ArcGIS Binding package last week, but there were a couple of functions that we didn't cover, and that's because these functions are only of use inside an R script tool. So the first of these functions is arc.progressLabel, and this allows you to add a description of the current operations being performed in R to be displayed in the GP tool dialog box. So this is really useful for giving your end user a status update as to what's going on with the tool, and you're actually providing the description. You're writing a string out that's going to basically tell the user what's going on. And this is helpful for debugging, as you can see at which point in the tool, perhaps the tool fails. You can see where it got to and where it failed. Also, you can use the arc.progressPos or progress position, essentially. And all this does is it sets the position of the progress bar for the GP tool. So you're going to provide a value between 0 and 100, and this will correspond to how far along you are in the GP tool. All right, so a few notes on outputting data from R. So something that should be taken into account when you use the arc.write function is the type of data set and the output location provided to arc.write will determine how that data set is stored. Data with spatial attributes will be saved as a GDB or a geodatabase feature class if it's stored in a geodatabase, or a shapefile if it's stored outside of that. And you can also specify these explicitly to the arc.write function. There are arguments, if you look at the help file for the arc.write function, that will allow you to specify all of these details explicitly. Tabular data, or more so a standard data frame that's provided to the arc.write function, will be saved as a geodatabase table or a DBF file. If a plot is created in an R script tool, so within the toolExec function, say you create a plot, one thing that's really handy is this plot will be actually displayed in a window, an R window, from within ArcGIS. So whenever you run the tool, the given plot will be output into its own separate window, and you'll be able to see the results of that plot. So that's a very useful way of outputting some sort of data as well. Lastly, you can use the print and message functions to print specific or certain details directly to the GP tool dialog box. So say you don't think it quite warrants outputting to some sort of table, it's just a sentence that you want to include or a small table, then you might want to use the print and message functions to accomplish that. Okay, so let's get right into the tool template. Let's open up RStudio and I'll show you the basic R tool template. So I would recommend you could use this for building your own tools. This is all available in the GitHub repo that I've linked to, and I'll be linking to again at the end of the presentation. So this is a very basic template. So as you can see, as I mentioned before, the toolExec function is being defined, and it's saying equal to function, and then you're specifying the two arguments, in params and out params. Each one of these will be a list. Once you're inside the function, inside the curly braces, what I think is best practice for generally dealing with R script tools is assigning each one of these list items to its own variable that's perhaps more explicit and explains exactly what that input parameter corresponds to. So you can access an item from a list using the double square brackets right here. So this will be the first item, and this would correspond to the order in which you provide parameters to your GP tool. So the first parameter will be in params 1, second parameter in params 2, and so on. The result will be the out params. Well, that's what we've stored it as here at least. And generally at the end of a tool exec function, you're going to return the out params. And this will bring in whatever you wrote out to your out params. It will bring that into your ArcGIS environment in your workspace, and you'll be able to see your results. If you want to print some standard details like the number of input parameters, you can use the length in params function and use the print function here, and this will print that right to your GP tool dialog box. Or you could actually print the value. This could be useful when debugging. Say you're unsure of the type of value you're working with. You could go print and then go class of input value, and you could determine what kind of input you're working with there. And I should there we go, save. And lastly, the arc.progress label. You can pass a string, and this will change what's being displayed in the GP tool dialog box, as well as the progress position, which will change the point in which the progress bar is. So this will be halfway across at 50. Okay, so pretty basic, but all of your tools that you build for our script tools are all going to follow the same general format. Let's go back to the presentation quickly. And actually, sorry, we're going to go right back to RStudio. So the first example, now that I've shown you a tool template, I want to walk you through the basics of an R script. And what we're going to use is we're going to use a one-way analysis of variance, or a one-way ANOVA tool as the example, as this is a pretty simple statistical method that most people will have learned in their first year statistics class. So essentially you're looking at different groups from a population and seeing if one of these groups has a different mean for a given dependent variable. So let's go back into RStudio and we'll look at our ANOVA tool right here. And right away you can see we're still following that same exact form. Tool exec equals function, in params, out params. So the first thing you're going to want to do in any tool is you're going to want to load the packages up that you're planning to use. So right here I've set an arc.progress label, loading required R packages. And if you remember from last week, we used the load packages function. So I'm going to do that right now, load up our packages. And we define this function actually right within the tool. So we have our tool exec function that ends right here. And then in the same file, we're including another function that's a helper function. So this is the load packages function. And if you missed last week, basically all this does is it checks if a given package is installed as required. If it's installed, it loads the package. If it's not, it will install the package and then load it. So it's just a nice tool to have, especially in an R script tool where perhaps your end user doesn't have all the same packages installed as you do. So it's good to check this and make sure that all the packages are correctly installed. So I'm going to show one thing I think I'll recommend is, let's talk about this first. Here we are getting the parameters. We can see that we have our in params 1, so we have 4 input parameters and 2 output parameters. And these are corresponding, we're going to assign these to variables. So source data, response variable, grouping variable, n groups or number of groups, and then our output parameters are a statistics table and an ANOVA table. So what I'm going to do is that generally in a tool you'll be assigning these input parameters to variables. But what if you want to test that tool before you actually build the tool in ArcGIS? What I like to do is provide references to basically hard-coded values. So I'm going to uncomment this little bit at the bottom, and I'm going to load in different values for the source data, all of the input and output parameter variables essentially. So then we can test and walk through the tool to ensure that it works before we try to hook it into a GP tool in ArcGIS. One thing I should note is that here I'm loading the ArcGIS Binding package and the arc.check product, but if you're running an R script tool, you do not ever have to require or use the library function for the ArcGIS Binding package. This will be done so automatically from within ArcGIS for desktop. Okay, so just quickly go through some of these parameters. We have our source data. So this is just the Toronto crime data set, a location of that. The response variable we're going to look at today is the number of murders that were committed in each given neighborhood. So this is the crime data set again. So this is the dependent variable that we're looking at. And now I should explain exactly what this tool does. So I have something called a grouping variable. And what we're going to do in this tool is given a variable, so this one's going to be the equity score variable. And the equity score can be thought of, it's an independent variable. You can think of it as sort of an indicator of socioeconomic status, which measures the total inequalities or inequities experienced by a given neighborhood. So the lower the equity score, the lower the socioeconomic status of that given neighborhood. So what we're going to do is we're going to provide the equity score for each neighborhood, and we're going to group our data set based on that equity score. So we have our grouping variable as the equity score, and then the number of groups we want to group that into is 5 in this example. And then lastly, we have 2 output locations. We have the r-arcgis data GDB summary stats table and the ANOVA results table. And these are both going to be tabular outputs. They're not going to be spatial outputs. We'll cover working with spatial outputs in a later tool. So let's start walking through this tool. So essentially we've defined all of these. And sorry, I should actually, before I go any further, I need to make sure that I comment these out, because if you do run the tool and these are uncommented, you may run into errors as these variables are being defined in 2 different locations within the script. So I'm going to scroll up and I'm going to walk through the tool. And this is a very simple tool, but I'll walk through basics behind the code. So the first thing we're going to do is we're going to load our source data, so the Toronto crime data set, and then we're going to use the arc.select function to create a data frame from that data set. So we're going to say take our data that we just created, and we're going to say for the fields, we're only going to need access to the response variable, so the murder count, and then the grouping variable, which is the equity score. So we only need to access those, therefore we can specify those fields in a character vector. If we want to check out exactly what we got, we can go view data df. And we see we only have these 2 columns and we don't require the neighborhood in this case, as we're going to be grouping by equity score. So let's do that. Let's group by equity score. The first thing we're going to use is we're going to group data into quantiles using the group field. So this is a one-way ANOVA, so that requires that all of the groups are of equal size. So we're going to use quantiles to accomplish this. And using the same function we used last week. And we're going to use the same dplyr syntax as well with the forward pipe operator. So group df equals, we'll take our data df, or basically our crime data, and this is a function that I haven't talked about yet, but I'll briefly mention. It's called mutate, and what mutate does is it adds a column to the provided data frame. So here we're adding a column to our data underscore df, and we're saying mutate, and we're going to say the new column is going to be named group. And I kept this pretty generalized because I don't know what type of data they're going to be feeding into this in this function. It can be any type of data, so I don't want to make sure that I'm not making any sort of specific references to crime data. So mutate, and we're going to say we're going to create a new column or a new field, call it group, and this is going to be equal to the quantiles of, take our data df group fair. So what is that? I'll show you that in the console. So data df underscore, and then you can use double square bracket notation to pass a variable to a data frame, and this will specify a specific column. So that's actually the group fair, if you remember, is equity score. We defined it right here. So that's the equity score column from the data df data frame. So what we can see is this is actually going to give us the exact same result as doing something like this, which is what we used last week. But instead, we can pass a variable that contains the name instead of actually having to explicitly state it. So all we're doing here is we're saying for the data, for the equity score column, group it into n groups. And we defined n groups as 5. And then lastly, we're going to group our data set using that. So let me just show you the output very quickly. And that will probably help you understand what's going on here a little bit faster. If we see this, now we've got a group field that groups by equity score. And if I sort, we can see that as the group increases or as it ascends, so does the equity score. So these are basically the lowest equity scores are in group 1, whereas the highest equity scores are in group 5. Okay, now that we've done that, let's calculate some basic summary statistics. So we can use the same function as we used last week, the summarize each function. First, you want to define a character vector of the functions we want to evaluate. So we have the mean and the SD that we want to calculate, or the standard deviation that we want to calculate. So let's define that. And now we're saying summary DF equals grouped DF. And that's important that we're referencing the grouped data frame, as that's required. It's going to summarize based on each group that we defined before using the group by function right here. And we're going to say, so this is a little bit confusing and a little bit outside the scope of this tutorial, but there's an underscore at the end of summarize each. And this is this idea in R of non-standard evaluation versus standard evaluation. And I'm sure if you want to read about this, you can search for this on Google and you'll be able to find a lot of different results that will explain this in greater depth. But essentially the main difference here is if I did not provide this underscore at the end of summarize each, then it would look to summarize based on a field named response var. It wouldn't look at the value stored in response var. It would actually look for a field from the data set that was called response var. So instead, if you include the underscore, it actually evaluates and looks to see what's stored in that variable. So therefore, the response var is the murders field. So therefore, we use the underscore to provide this. And this is very common use if you're providing these types of things in functions, because oftentimes you're storing variables and you're abstracting the string and you're storing that in a variable. So instead of trying to listen to what I just said, let's just see what it resulted in, because I'm sure I didn't do it that much justice. Let's see, summary. There we go. And what we can see is we have summary statistics for the mean amount of the murder count and the standard deviation for each equity score group. So as you can see, the first group seems to have a higher mean, or a different mean than pretty much all of the other groups. So we don't know if that's statistically significant or not yet, but we can check that out by continuing to go through the tool. So what we want to do, one of the outputs for this tool is the statistics table that we just generated. So we're saying if not, so using the exclamation mark for not is null. So essentially checking, making sure that the stats table is not null. And the stats table is the final location we are outputting our data set to. Remember, summary stats. So just make sure that the user provided a value for stats table. And if they did, then write our stats table, write our summary df out to that location. So just same thing we've been doing before using the arc.write function. Now let's create a box plot. We can create a box and whisker plot using our data sets. So we say, let's take our grouped df response variables, so essentially our murder field, and we'll model that by some set of linear predictors. So that's what this tilde means. We're saying we're modeling this dependent variable by these independent variables. So what we're saying here is model the murders by, and then we're only going to provide one linear predictor. We're going to say grouped df group. And what is this? This is the equity score group we created right here. Right here. This is the equity score group column. And then we're saying passing two extra parameters to this function, the y label for the y-axis and the x label for the x-axis. So let's just output this very quickly and you can see the result. It's just a standard box and whisker plot, and you can see for group 1 it seems as though the mean is higher than the rest. But that's why we're going to perform the ANOVA, so we can see if this is statistically significant and we can reject the null hypothesis. Okay, so that's the last step of this analysis. ANOVA fit, so we're using the AOV function to perform a one-way ANOVA, and we can see, we can look at our response variable, same model formula as we were defining before, response variable modeled by our grouping variable or our equity score. So that's all you have to provide to the AOV function, and then you can gain, that's going to fit a model, an ANOVA model, and now we can get a summary from that model. So summary of ANOVA fit equals ANOVA results. And let's print these results to our console. And it has a few different things, but what you need to look for is you've got your degrees of freedom, sum of squares, mean square error, your F value, and then you've got your P value over here. And what we can see is that the P value is quite small. It's 0.01. So depending on your alpha and your confidence interval, I'd say this is a relatively significant result, and we can reject the null hypothesis that all the means are equal. So great. We've done that. last thing we want to do is write our ANOVA results to a data frame and then return that data frame the same way we return the stats table, check if the user provided an output, and then send that over to ArcGIS. And that is the last step. And then you're going to return your out params so that these things will be actually loaded into the user's workspace in ArcGIS. So I know that was we went through a lot of different lines of code, but this is a very simple tool in general. If you're familiar with a lot of these R functions and doing ANOVA in R, you'll know that this is fairly straightforward R code. So let's go into ArcGIS Pro and let's see if these results actually were generated. So here's our ArcGIS Pro. This is the same project we were working with last week. We can go into our ArcGIS data geodatabase, and we can see ANOVA results was written. I should go back into R very quickly. I never executed this line of code. So there we go. Now if we go back into ArcGIS, refresh, and wait for it to refresh, and there you go. Now our summary stats and our ANOVA results are in here. We can bring these into our ArcGIS workspace and see in our table of contents they've been added. If we want to open these and see, this is the table. So one thing, this is just a tool for testing. I would probably change a few things about this tool. For example, I would change this grouping column to actually say the variable that was used to group that. So group underscore equity score or something of that nature. I didn't do that to keep the tool syntax relatively simple, but I would recommend doing that in a future ANOVA tool. Say you want to improve on this, make a pull request on my GitHub repo if you want. And we can also open our ANOVA results and we see we have our p-value, and the same thing is true here. Maybe change this to say p-value for our f, and we have our, maybe just change these short forms to be a little bit more explicit. But you can see the results were output into ArcGIS. So let's actually let's delete these so we don't run into any sort of overwrite issues. And let's go back into the presentation actually. Okay, so now we've written that script. What we have to do now is build an ArcGIS script tool within ArcGIS. So we're complete with our R script, and now we can create the GP tool to connect to that R script. So this is the exact same process if you've ever created a Python script tool. It's the exact same process, except that now you'll be providing an R script for the script file. The only thing that's really important is that you have to ensure that the parameters are ordered in the exact same way they are referenced within the R script. I've included a very basic outline of building an R script tool in ArcGIS Pro in the Documents folder of the GitHub repository, so you can find it there. And that's really working with another R script that I've already written out for a very basic summarize tool. But let's go through that process right now. Okay, so we have a toolbox here, a custom toolbox that we can use. And you can see I've actually already created this tool, but we're going to create a copy of this tool because I want to show you the process of building a tool. So we can right-click this toolbox, click New, Script, and let's call this r-ANOVA copy, because we don't want to have any sort of naming conflicts. And now, where you'd normally just be specifying a Python script, you can go in, and in our R folder, in our tools folder, we can see our ANOVA tool.r, select that. And you see, now that we've installed the r-arcgis bridge, we can actually just provide an R script file. That's great. So now let's go to the parameters. And this is what I was talking about earlier. We'll go quickly back into R to see the ordering of our parameters. We want to make sure that these are correct. So we've got our source data, response var, grouping variable, and groups, then our last two output parameters. So let's make sure that we follow that order in ArcGIS Pro or this will not work. So the first one, our source data, input features. We need to specify the data type. This is going to be a feature layer. And I believe that's all we'll have to put in for this one. You see there's a lot of different categories. Say you wanted to specify the symbology for an output layer. You could do so by specifying a layer file here. Okay, the next category is the response variable. Or sorry, the next parameter is the response variable. And this is going to be actually a field. And the thing is, we want to make sure this is dependent on our input features. So this will derive the fields based on the input features that are selected. And I'm actually going to add a filter as well because we only want numeric fields. So we can specify this will only allow us to see different numeric fields. Now we have our grouping variable. It's pretty much going to be exactly the same as our last one. We're going to specify a field. And it's going to be dependent on our input features, and we're going to make sure it's numeric. Perhaps you could change this tool as well. Say if you wanted to group by a nominal category that's just some word, you could change this function. But for this particular ANOVA function, that's not an option. But I could probably modify this to give you the option to do that as well. Number of groups. This is actually just going to be a long or an integer. And those are all of our inputs. Great. Now we have to specify our two outputs. So I'm saying output summary stats or statistics. This is going to be a table. And make sure that you change the direction to output. And then the last one here is output ANOVA results. And that is the last possible parameter. So that's just showing you exactly how you go through and specify all these things. Make sure this is output. Don't want to make any mistakes here. And I think we're good. I think we're okay. So we'll see, I guess. Moment of truth. So now our tool has been added to our toolbox and we can test this. So let's open up the tool. And one thing you'll notice is that if I mouse over this eye, there is no description of each one of these. And this is because we haven't provided any documentation. If you wanted to do that, you could right click, then select view metadata. And I'm going to close this tool actually so you can see this. And now we're selecting the r-ANOVA copy and we can go edit. And now we can actually add a summary, some tags, and for each different parameter, if you put in a dialogue explanation, that's going to give you a tooltip within the tool. And this is definitely recommended. Just in the interest of time, we're not going to be doing that today. But this actually, the original version of the tool does have tooltips included with it. Okay, let's try out our tool. So let's use our Toronto crime. We'll pick a different response variable. I'm just going to pick a random one. I don't know if this will be significant or not. Look at thefts. I think I'm going to stick with equity score because I don't have too many independent variables here. Let's do 4 groups this time. And let's change the name of the output. Call this Toronto crime summary stats. And this one, Toronto crime ANOVA results. Okay, so let's see if this works. Fingers crossed. We very rapidly put together this tool, and actually, if you look down here, it will give you updates on using the arc.progress label. The thing is, this tool will run very quickly, so we might not be able to see that. And there you go, completed successfully. And on my other monitor, which I'll bring over here, you can see we actually have the box plot that was generated from within R, and we see here there's probably not going to be a statistically significant result because it looks like the means are all quite close. So let's close this, and we'll go into our results that were just added. And I'm going to actually just check the ANOVA results. And you can see our p-value is very high, so we don't have much, there's no significant, and we could fail to reject the null hypothesis that there is a difference in means between groups. So that's a very basic tool, and it's only doing tabular outputs, but it's pretty much the exact same process for spatial outputs. And let's do that right now. Let's go back into the presentation. So I showed you a simple tool. If you want to look at some more complex tools, you can use the r-arcgis sample tools GitHub repository. And I linked to this in the previous presentation. It's right here. And it contains several more complex tools. Specifically, it has a model-based clustering tool for clustering points based on their spatial location, and then a semi-parametric regression tool. And also, if you want to have some more basic examples to look at, you can check out the ArcGIS Binding package examples folder. And this is a link to the GitHub repo where you can view all of these. Okay, so I'm going to attempt to quickly walk through this model-based clustering example. I'm going to give you a disclaimer. I don't know all of the code that's going on behind the scenes, but we're just going to show that it follows the same general form as the last tool we just showed. So here is the clustering tool. One thing you'll notice right away is they're actually using this arrow assignment symbol, and It's doing the same thing as the equal sign. There are very, very slight differences. This is a common sort of argument within the R community as which one people should use. I'd say probably more formally, most people use the arrow. But as long as you're consistent throughout your script, I don't see a problem with using either. Just try to make sure that you're using the same one consistently. And also, if you're an RStudio user, a nice shortcut for the arrow is to do Alt-dash. You get an arrow right there. So that's just a little tip. So right away at the start of the script, they're doing the same thing as the load packages function was doing. Essentially, they're checking if SP and mclust are installed, and then they're installing them if they were not, and loading up the required packages. Assigning all of the input and output parameters to different variables in our dataset, opening a connection to the source dataset, selecting only the object ID as they don't need anything else, as this is clustering based on the spatial location. Then they're grabbing the shape info from that data set, and that actually gets you the X and Y coordinates, and then creating a data frame from those X and Y coordinates, as these are required for this function they're using down here, mclust-bic. So what they're doing here is they're basically generating a number of different statistical candidate models, and they're using the Bayesian information criterion, which I'm not going to explain, to select the best fitting model for clustering these points. Okay? So they're using mclust-bic, and then they're taking a summary statistics for that model and printing those to the GP tool dialog box. They're performing some more analysis here, including conditional probabilities for each point that it actually is part of that cluster. And after that, and if you want to go through this yourself, you can actually read through this code, no problem. They're storing all the results in a data frame that includes the original data set and a few different fields that are not included in the original data set. Lastly, they're writing the result data set out to a spatial file or to a shape file or a feature class. So they're doing the same thing as we did before, checking that the output table was defined, and then they're using arc.write, but you'll notice that they specified one extra parameter, and that is the coords parameter. And this allows them to specify some spatial attribute info about the file, and this will allow it to be exported to a points shapefile. And now after that, pretty much everything else is optional. So you'll see if is null out ellipses. The reason why they're checking for this is it's saying if this parameter, this output parameter was provided by the end user, then perform this analysis. If not, you don't have to. There's no reason. So it's an optional parameter in the GP tool. So that's for standard deviation ellipse, density grids, you can read through this, and lastly, simulating different points given that statistical model, the best fitting model that was chosen. A few helper functions are included at the bottom of the file for simulating and creating ellipses. And yeah, so you can see there's obviously a lot more complex R code going on behind the scenes, but the general form is exactly the same. So let's go into ArcGIS and let's play around with this tool. So I'm going to use the data set that was provided from the R samples toolbox. Again, this is all available on GitHub. So this is the model-based clustering tool. And let me open this data set and I'll add spruce trees to our map, which is just a number of different points of trees, and our forest study area, which is a study area for these trees. So let me zoom to the layer so you can actually see these trees. There you go. And now let's run our model-based clustering tool. Select spruce trees. We already have a name for this and say, call this SD ellipses. Density surf, I'll just say density and sim points. And these are not great names, but in the interest of time, I think they'll work. So let's see what this tool actually will output. And it has a number of different spatial outputs that you'll see. So we can see if we expand sort of the tool, the different messages that are printed to the console. So we have some general statistics based on our summary statistics based on our BIC, our Bayesian information criterion, that's selecting the best fitting model. And what you see right now is we've got a lot of different outputs on this map. So I'm going to toggle some of these off and we'll sort of address them one at a time. So you can see it actually clustered all these points based on the statistical model. And the size of the point, and the color indicates the cluster, and the size indicates the conditional probability that that point actually belongs to that cluster. And how did they do this? Well, if you go into the parameters the properties, of the model-based clustering tool, we can see under the parameters that in the symbology, a layer file has been defined, and this is defining the symbology for the output from this tool. So that's a very useful thing to do if you want output to be displayed in a specific way. We also have standard deviation ellipses for each cluster. If I toggle this on, we have a density surface of where trees are more likely to be. And lastly, based on the model, we've got simulated points using the fit model to generate these. So these are based on that density and based on where you expect to see points. These are just randomly simulated points from the model. Very cool. Okay, so the last step of this workshop, the last thing we're going to cover is our script tools and integrating them in with ModelBuilder. So our script tools can be incorporated into models that are built with ModelBuilder and ArcGIS. And this is really, to me, very, very powerful and a great way to use our script tools. So it allows you to construct complex workflows that are powered by by R. You can include some Python tools that you've been using and even native ArcGIS GP tools. And you can include these all in the same workflow. And I don't really think I've ever been able to do this effectively in the past. And I would have loved to do this because you can draw on the best algorithms are out there. Say you want to do some sort of analysis in R, you have another thing you'd like to do in Python, and then lastly, maybe some geometric operations, do some simple dissolves and clips or whatnot in ArcGIS. You can use all the best tools for the job. So using a ModelBuilder workflow for this is very, very useful. And in the RSample Tools toolbox, there's a model-based clustering enhanced example that you can use to accomplish this. And I'll show you this right now. Let me go back in. And as you can see in the RSamples toolbox, you can see there's a model included here. So if we go right-click, edit, we can see the model. And I'll zoom in a little bit, and we can see the first step is actually, this is the R tool. This is the R script tool, the model-based clustering. But once we're done with that, we take the outputs and we create these in polygons. We do a dissolve, a clip, another clip over here. Lots of different different operations we can perform. Kernel interpolation, so kernel density surfaces and whatnot. So this is great. And you can see you can construct these rather involved workflows. So let's run this tool. I'm not going to save the changes I made. And actually, let me remove the results from our map and toggle back on our spruce trees. So a parameter that this tool takes is a clip. So we have a study area that we've defined right here. So let's run this tool. Select our spruce trees. For our input polygons, we'll say the forest study area for our clip. And then for our cluster, we'll call this clust_polys. And I'm actually not going to output the standard deviational ellipses, as we've already shown that. And I'll show that these are optional. And if you do not provide anything for them, the tool will run totally fine anyway. Okay, so let's start running the tool. We can see the outputs. We'll see there'll be a lot more in the messages this time because we're executing a lot of different tools. Create these in polygons, dissolving, doing a clip, and then finally our kernel surface at the end. And our tool is finished. And we can see the result here. So we've actually generated different polygons. We've sort of broken the polygons into areas where the clusters would begin and end. We've also got the same points that we created before, clustered based on location. And if we toggle off our forest study area, we can see we've created a raster underneath, basically showing different probabilities. So where are higher probability areas for trees to be? And if we would have included standard deviational ellipses, we would have been able to see those as well. So this shows just how powerful using these tools in conjunction with one another in a ModelBuilder workflow can be. All right, let's get back into the presentation. So that's pretty much the gist of what I wanted to show you today, was just going through these different and showing you how to build our script tools. Of course, if you have any questions about this workflow, I'm more than happy to answer those. So please send me an email or ask questions at the end of the presentation. So just a few notes before I go on. I really want to encourage, again, we mentioned this last webinar, but we're very interested in having any member of the R community, so anybody attending this webinar, to contribute to the r-arcgis bridge. And specifically, building tools like we built today would be very, very valuable. We'd make sure you get full credit for your tools. And if you have any questions about different documentation, different parameters for the tools, of course, contact us and we'll get back to you as soon as we possibly can. If you're an R package developer, we'd really love to collaborate with you. We think this is a great way for you can push your package to the widest possible audience and get full credit for all of the work you've put into your R package. So again, anybody, please contact us. As far as resources go, you can download the RStudio project and the ArcGIS Pro project used during this webinar at this GitHub repo. And I would caution you that last week's materials, if you downloaded this webinar last week, please go and download it again because I've updated the GitHub repo with a lot of new resources specific to this week's section. The video from last week is already available on YouTube, so the Integrating R with ArcGIS Part 1 video recording, right here, you can access it, and we will be uploading this video to YouTube as well. Lastly, if you're just looking to get some free R resources, so these are not specific to ArcGIS, this is just general R stuff. So one place I've been to before and I've recommended is the DataCamp site. And DataCamp has a free introduction to R course. And what's great about DataCamp is that there's a REPL or a sort of an R console in the browser that you can use. So you don't even need to be working on your own computer. You can do this all within the browser. Also, as I mentioned, a lot of the different packages we used were developed by Hadley Wickham. And Hadley Wickham has a number of different books that are very, very good. So two of which I've read and I'd recommend are the Advanced R book and the R Packages book. And both of these are totally free, available online. He's currently working on a new book on data science, and you can actually access where he is in the book. If you access the website, you can see the progress he's made and sort of also if you have any corrections, you can submit those to him. So I'd recommend checking these books out very much. Again, I'd like to thank the r-arcgis Bridge team at Esri US. So this includes Sean, Mark, Steve, Dimitri, and Konstantin. So some of these tools today were developed by the r-arcgis Bridge team, specifically the Sample Tools Toolbox. So obviously none of this would be possible without them. Many of the packages we use today were developed by Hadley Wickham as well as RStudio. And the R spatial community. None of this would have been possible if these R spatial data types weren't already available for us to take advantage of. So this is really, really dependent on all of these people, or we would have no way to use this r-arcgis bridge. Okay, so last information. If you need to contact me, you have any questions, my email is cplouffe@esri.ca. If you have more general questions about the r-arcgis bridge, you can contact them at r_bridge@esri.com. And again, I will say that we'd really love to get some feedback. If you have any feedback as what you want to see included in the r-arcgis bridge, please send an email, because unless we get these emails, we don't know what people are looking for. And if there's enough demand, then we'll go out there, especially the r-arcgis bridge team, and they will implement it. So unless there's feedback to steer the direction of the r-arcgis bridge, it's very hard to know where to go next. So please, please contact us. All right, thanks a lot. Thank you very much for attending both webinar series.